Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics. Yes, here we are helping you to achieve your dream, that is getting that 60 out of 60 in physics, where if you follow our series, you will definitely be very close of getting that 60 marks. Now we are discussing currently the chapter atom. We have already completed part 1 of atoms, where we have discussed about Rutherford's experiment and atomic spectra. Today we are going to discuss about Bohr's model and then also everything related to Bohr's model, its failure, etc. We are going to discuss in today's lecture, so don't go anywhere. Also there will be a lot of questions answered during this discussion, and tomorrow I will be discussing the PYQs from this chapter. So if you are not watching regularly, you have to watch all the videos regularly. And let's start with this chapter. Before I start, I have to remind you that you have to join our WhatsApp group. The link is given in the description. There you will get the PDF of this lecture and all the previous lectures. Also you will get the KCET Premier League question paper from this link, from this WhatsApp channel. So don't forget to join our WhatsApp group. Click on the bell icon in that WhatsApp so that you get the notification as soon as we are uploading one video. Now let's look into the list of content of today's lecture. What we are going to discuss? We are going to discuss Bohr's atomic model, then we will discuss energy levels, then we will discuss line spectra, and then lastly de Broglie's explanation about Bohr's model. Okay, so these are the main 4 points that we are going to discuss. So let's start with Bohr's atomic model. 3 postulates of Bohr. So as we have discussed that previously, Rutherford's model was basically based on the fact that there was a positively charged nucleus, and electrons are orbiting around it. Okay, electrons are orbiting around it, but this has some drawbacks. First of all, the radius of this orbit can be anything. That's what Rutherford said. Rutherford said, okay, as long as it obeys the repulsive force is equals to the required centripetal force, it should obey my law, and it should rotate in the around the nucleus. But there was a classical theory of electromagnetism. Okay, if you remember in the electromagnetic wave chapter, we have said that if the electron accelerates in a magnetic field or in an electric field, if the electron accelerates, it produces electromagnetic wave. Okay, and because of this production of electromagnetic wave has energy, so that energy should come from the acceleration of the electron. As soon as the electromagnetic wave is generated, the energy is lost by the electron and slowly it dies down. That was the fact, unless and until someone is continuously providing that energy. Right now, if electrons are rotating around this positively charged nucleus, then there will be some interaction between this electron and this proton, this nucleus, right? So because of this interaction, the electron will accelerate and it will produce electromagnetic radiation. Okay, and as it is producing electromagnetic radiation, it is losing the energy. So slowly its radius will decrease, and slowly it will jump in the nucleus and it will die. And there were some calculations. According to the calculations, it can be shown that the stability of the electron is 10 to the power of minus 8 seconds. Stability of this atomic model is died even before it was actually able to establish itself. So even though the Rutherford gave the basic idea, it was failed miserably because it was not able to explain why this is not happening. Right? So basically, what is the implications of this? If this atomic model is to be true, okay, then the world that we are living in would have ended 10 to the power of minus 8 seconds after the first creation of the atom. Okay, as we know, during the Big Bang, okay, during the Big Bang, particles were created. Okay, after some time atoms was formed. Once atoms are formed, as soon as atoms are formed, after 10 to the power 8 seconds, everything would have been destroyed. There would have been nothing left. Okay, and there would be no sun, there would be no earth, there will be no you, there will be no me. So everything was not be possible if this atomic model is correct, right? Because we all are made up of atoms, okay, complex atoms, molecules, etc. So it is not possible if an atom is not stable, okay, then the world is not possible, right? So that's why this model was very, very hugely flawed. So something has to come. So as I said in our previous lecture, Niels Bohr was one of the student of Rutherford, okay, he was studying under Rutherford, and where Rutherford left, he took up and he said, okay, we cannot have this model as it is, so I have to define few things, I have to set certain boundaries. What boundaries? He said, first of all, an electron in an atom could revolve in certain stable orbits, only in certain stable orbits. So he said electrons cannot orbit in any random orbit, there has to be some certain specified fixed orbit, okay, without the emission of radiant energy. So once it is orbiting on that such fixed orbit, okay, it will not radiate that energy. So if suppose this is one of the such fixed orbit, so when the electron is orbiting around this orbit, okay, electron will not radiate, electron is not compelled to radiate electromagnetic wave, so it will not lose any energy and it will continue to rotate. So there are some fixed orbits, okay, fixed orbits, and only in that fixed orbits electron can stay. If the electron is in between two positions, it has to either fall back or it has to go back based on where it is, okay, generally it falls back, okay. So without emission of radiant energy, contrary to the predictions of the electromagnetic theory. So first of all, he said this is fixed orbit, and if an electron is staying there, it will not radiate any energy. So this is the first thing he contradicted. He contradicted with classical electromagnetic theory. So classical electromagnetic theory, even though it is correct, there are certain things it was not able to explain. So that's why there are new theory was required. Atomic theory based on from atomic theory, quantum physics also started. So these are all linked together. So in atomic electromagnetic theory, quantum electromagnetic theory is completely different than classical electromagnetic theory. So that is much more complicated. So that's why this quantum electromagnetic theory can explain this phenomena, but classical theory cannot, okay. The electron revolves around the nucleus only in those orbits for which the angular momentum is some integral multiple. So he said that not only this orbit can be arbitrary, there has to be some limitation on this orbit also. If the electron is orbiting around this orbit, okay, then its angular momentum, we know that angular momentum is there, okay, L is equal to I omega. In rotational motion we have learned that some similar to linear momentum. But when an electron is orbiting in one orbit, in that orbit the angular momentum has to be integral multiple. Integral multiple means 1 time, 2 times, 3 times, 5 times, 6 times, like that, okay. It will be not possible to be say 2.5 times. No, 2.5 is not integer. So integral multiple means integer multiple, okay. So if you multiply it with an integer, then we call it integral multiple, okay. Integral multiple of h by 2 pi, where h is the Planck's constant. Thus the angular momentum L of the orbiting electron is quantized, okay. You remember that term quantized? We are studying that since we started the chapter electrostatics, where we said charges are quantized. So basically it has a minimum possible value, okay. And here L is given by nh by 2 pi. Here n starts from 1, 2, 3, etc. Okay, this is the basic meaning, okay. If angular momentum is integral multiple, it can take plus minus values as well, but we are not considering that, we are only considering plus values. So L is equal to nh by 2 pi. Now what is the minimum value of angular momentum? Yes, if you put n equals to 1, then that is the L minimum value. So that is the concept of quantization. In quantization there is a minimum possible value, okay, and we will learn what is the name of that minimum value. This is h by 2 pi, right? So h by 2 pi is the minimum angular momentum. Very important thing to remember. Okay, here n is L equals to 1 is called ground state. So L minimum is for ground state, the minimum orbital angular momentum. This is for ground state. This is ground state. So minimum angular momentum means this is at ground state. What is the meaning of ground state? So there are few states where the electron has the lowest possible angular momentum, that is called ground state. Okay, any other state other than ground state is called excited state. Okay, so when you get excited, you try to you gain energy and you are excited. But when you are not getting energy, so study physics. Arey sir, what are you doing? You are teaching me physics. I am not so excited. I am in my ground state. Okay, as soon as biology or chemistry or maths is coming, and maybe you love mathematics, I want to watch mathematics. So you are excited state, right? So ground state means when it is your normal state, or maybe you are studying, you are focused normally, then you are at ground state. Okay, and excited state means when you are have some extra energy, similarly to that of the electron. Also when the electron has the minimum possible angular momentum, that is minimum energy, then that is the ground state. When it has some higher amount of energy, then it is an excited state, right? Now the another last postulate of Bohr, we have already discussed two postulates. What was the first postulate? If you remember, first postulate is electrons are orbiting in the stable orbit. Second postulate is the angular momentum is a integral multiple of h by 2 pi. Now an electron might make a transition from one of its specified non-radiating orbit to another of lower energy. When it does so, a photon is emitted having energy equal to the energy difference between the initial and final states. The frequency of the emitted photon is then given by h nu equals to ei minus ef. So what is the meaning of that? Suppose an electron is orbiting around a nucleus at some orbit. Okay, so this is the initial energy. Okay, and there is another orbit. Okay, it has a final energy ef. Okay, and an electron orbiting around this orbit, it has the liberty to jump from here to here. Okay, this is a lower energy. As you go inner and inner inside the closer to the nucleus, the energy gets lower. So this is a ground state. This is ground state. This is say first excited state. Okay, first excited state or any excited state. Okay, so from this orbit to this orbit, an electron can jump. So electron can move only between these fixed orbits. Electron cannot jump arbitrarily from any point to another. Okay, electron cannot come, okay, I don't want to go there, I want to stay here. Not possible. So electrons have specific rooms. Okay, so for example, in your room, you can come out of your room and you can visit your parents' room. You can consider these are like rooms. Okay, one room is yours, one room is your parents' room. You can jump from one room to another room. But you cannot stay in the corridor, you cannot stay in the hallway. So you have to go from one room to another, right? So that is what they said, that when electron jumps from one energy to another energy, it emits a photon. Okay, and photon emission is denoted by this. So an arrow like this, a curvy arrow like this. Okay, and this frequency of the emitted photon nu is given by this. Okay, so suppose this has some energy, say 6 electron volt. Okay, this has some electron, say 2 electron volt. Okay, so 6 minus 2, this is usually negative. Okay, we will see that as well. But so ei minus ef, not ef minus ey. Okay, because electron jumps from higher energy to lower energy. You have to remember that electron jumps from higher energy to lower energy. Okay, so ei minus ef equals to h nu. Nu is the frequency of the photon. You can determine the frequency, right? Radius of nth Bohr orbit. Now you should remember that one small point. The Bohr atomic model was very applicable to hydrogen atom. Okay, so it is a very appropriate for hydrogen atom. The atomic spectra that we have seen, Balmer series, Lyman series, Paschen series for in our previous lecture. So this is very applicable to hydrogen atom. For any other atom, this is not super applicable. That is one of the drawbacks. Okay. So when we say nth Bohr orbit, that means nth hydrogen atom. Okay, nth orbit of hydrogen atom. So nth atom orbit means what? Suppose there is a nucleus, 1 orbit, 2 orbit, 3 orbit, 4 orbit. There are multiple orbits, right? Infinite number of orbits are possible, right? So we say, suppose this is orbit number 1. This is n equals to 1, this is n equals to 2, this is quantum number, this is called quantum number, right? If you have studied that in your chemistry class, this is called quantum numbers. N is equal to 3, n is equal to 4, like that. Okay, so for some arbitrary orbit, say n, what is the radius of this? What is the radius of some arbitrary? It can be, if you put the value of n correctly, you can get all the orbits, right? So radius of the nth orbit is directly proportional to n square. We do not need the exact expression for your KCET exam, but you need to remember that radius of nth orbit directly proportional to the square of the quantum number. Okay, so for example, if they say the radius of first orbit is say x, okay, what is the radius of the fifth orbit? Okay, radius of first orbit is x. Okay, what is the radius of? So it is radius of fifth orbit is equals to 5 square r1. You should remember that. Okay, or you can also remember that Rn is equal to n square r naught. Okay, so this is the nth orbit of the Bohr, and this is called Bohr's radius. That is the minimum radius of when you put n equals to 1 in the actual expression, whatever value you will get. Using that, you can calculate the radius of any of the order of the orbit. Okay. Energy of an electron in Bohr orbit is given by, so this is the energy of an electron. Okay, so as I said, this is actually negative. Okay, so energy of the electron in nth orbit is given by minus 13.6, very important number, divided by n square eV. Now what is the energy of electron in the ground state? In the ground state E is equal to 1, so it will be minus 13.6 eV. So when an electron is at the ground state of an hydrogen atom, okay, so nth Bohr orbit, as I said, this is only applicable for hydrogen atom. So this expression is also valid for hydrogen atom. For any other atom, this is not applicable. Okay, for any other atom, this is not applicable. This is mainly for Bohr orbits, Bohr expressions, and this is only for hydrogen atom. Okay, Bohr orbit means hydrogen orbits. Okay, you should remember that. Now let's look into this question. The ratio of area of first excited state to the ground state of orbit of hydrogen atom is. Very interesting question. So we know that what is the formula for area? Area is pi r square. We know that all the Bohr orbits are circular in nature, so the area should be pi r square, right? Now for area of any nth orbit will be Rn square. Okay, so we know that what they have said, first excited state is when n equals to 2 and ground state is when n equals to 1. So don't get confused. Okay, first excited state does not mean n equals to 1 and ground state does not mean n equals to 0. There is no 0 here. Okay, be careful, there is no 0. Okay, so what we are trying to find? We are trying to find area of the first excited state, that is A2, divided by ground state, that is A1. Okay, so what we are trying to find? Pi R2 square divided by pi R1 square. Okay, this is our target to calculate. Now what else? We know that R2 depends on, we know that Rn depends on n square, right? All everything else is constant, so they will cancel. So what we will get? We will get 2 square divided by 1 square. So it will be 4. So A2 equals to 4A1, or we can write this as, we can write A2 is to A1 equals to 4 is to 1. Okay, so if you see, only correct answer is C. Okay, 4 is to 1. Don't get confused. See what is first, what is second. First is first excited state to the ground state. So first excited state to ground state, that means 2 means it will be in the denominator, in the division. So it will be 4 is to 1. Right? Easy question. If you have any doubt, don't forget to mention that in the comment below. Now, energy level diagram, another important thing. Okay, so if you see that when we consider the ground state, this is ground state. So I said ground state n equals to 1. So this will help you to remember how you can remember different energy levels. So this is associated with a particular energy. That energy is 13.6 eV, minus 13.6 eV. Now for n equals to 2, the corresponding energy is minus 3.4 eV. For n equals to 3, the corresponding energy is minus 1.51 eV. So if you remember, what was the formula? En equals to minus 13.6 divided by n square. Okay, so as you go higher up, okay, you will see that all the energy levels are getting very close to each other. Okay, they are actually approaching 0. Okay, and at lower energy levels, the gap is significant. Okay, so if after 13.6, next is 3.4. Okay, so after that it is 1.5. So it is almost 10 eV first difference. Second is half. Okay, third is again half almost. Then they are getting closer each, right? So initially the energy gap is very high. So once you close that gap, the energy levels are very close. So this is very similar to success of your life. You can consider this graph as a point towards your success of your life. So if initially first jump is very difficult. So when you are studying, suppose you are studying physics, you are feeling bored. Oh my God, physics is so hard. I am falling behind. I am not able to study. What to do? But once you take that leap of faith, okay, first 2 stages are difficult. But once you cross these first 2 stages, next stages are very close to each other. So once you cross that hurdle in your mind that I have to study physics, physics is not hard, physics is not so difficult. If I understand physics, I have to spend some time with physics first. Then I can complain, okay, physics is hard, physics is easy. So once you cross that hurdle, okay, life will be much easier for you. You can simply jump from one energy level to another energy level. Okay, and again, if you come back to your ground state, everything will be same. So even if you move higher energy, okay, as soon as you write your KCET exam, again you will be back to ground state for your next level, next exam, right? So as long as you are alive, every day you have to jump this energy levels to achieve your goals. Once your goals are achieved, the final stage, okay, then you will be sitting at 0 energy, right? So 0 energy is our goal. Okay, so that is actually not 0. This is our 60 out of 60 in physics, right? Now let's move on. Let's solve the homework questions I gave you yesterday. The scientist who is credited with the discovery of nucleus in an atom is, I told you the answer, it is Rutherford. Okay, Rutherford is the scientist who was given credit for discovering the nucleus, right? Next, in Rutherford's experiment for head-on collision of alpha particles with gold nucleus, the impact parameter is 0. Head-on collision, so I explained that as well. Okay, so this is the gold particle, gold nucleus, this is alpha particle. For head-on collision, only possible when the impact parameter is 0. That is, it is going straight towards the nucleus, right? So the impact parameter should be 0 for head-on collision. Okay, now The line spectra of hydrogen atom, I already discussed this in detail, just to give you the idea that there are few series, Lyman series, Palmer series, Paschen series. Now why these are occurring, the reason I have not explained. The reason is that now I can explain that why it is happening. So we have seen that energy level diagram, right? So there was one ground level, okay, ground level has minus 13.6, then there was level 2, level 3 and so on. So when an electron, suppose at higher energy level, okay, jumps from this higher energy to the ground state, okay, you will get a corresponding electromagnetic radiation. Now when all of them are coming to ground state, you will get one of the series, okay. When all of them are coming to the, suppose every electron is now jumping to the second level, that is the first excited state, then you will get the Bohr series. Bohr series comes second. Similarly, when you get all the electrons are coming towards the third level, then you will get the Paschen series. Okay, Lyman series is for everything is coming at ground level. Okay, so Lyman series is when every electron is falling to n equals to 0. Bohr series is when everyone is coming to n equals to 1. Paschen series is everything is coming to n equals to 3. Similarly, there are more series. Okay, so but these are the three most prominent series. Okay, and when electron jumps from higher energy to lower energy, okay, it can stop anywhere, any possible steps, right? So if everything is coming to ground level, then you are getting Lyman series. Okay, when every electron at higher energy level going to n equals to 1 level, okay, they are stopping here, then you are getting Bohr series, and that is visible. That is to our eyes, this is visible, as I mentioned. Now, de Broglie's explanation. So what is de Broglie's explanation? De Broglie was, as I said, de Broglie was the first one to start the quantum mechanics. He said every moving electron can have a wavelength. Okay, so particle behaves as a matter radiation. That was the first part of de Broglie's theory. Second, he said that for an electron moving in nth circular orbit of radius Rn, the total distance is the circumference of the orbit Rn. Okay, so he said that this 2 pi Rn should be equals to n lambda. What is n lambda? Lambda is the wavelength of the electron. Okay, so electron, when they are orbiting in a fixed path, okay, it should have complete circle. Okay, so it should complete one full circle. What is the meaning of that? So suppose there is a wave like this, then another wave like this, another wave like this. So it has to close. Okay, for example, here the diagram that I have drawn, they are not perfectly closing. That means this is not a perfect thing for this diagram, right? But if they perfectly close, then we can say, okay, this is a they have a fixed wavelength. Now if this is the wavelength, okay, between distance between two peaks, as I said, this is the wavelength. Now there are multiple wavelengths are possible. Okay, this is one of the length. So suppose there are small wavelengths are also possible. Okay, so he said that the circumference of this Bohr orbit should be a integral multiple of the wavelength lambda. Okay, it can be 10 times, it can be 5 times, it can be 1 also. Okay, so that's how de Broglie tried to explain that why these orbits are fixed. Okay, and he said that when the electron is moving inside this orbit, they are not moving as a particle, they are not moving as a charged particle, but they are moving as a form of wave. Okay, that's what he said. Okay, and it was later on somewhat accepted. It was converted into electron cloud, etc. Electrons are you cannot directly determine what is the position of the electron. It is based on a cloud, etc. You might have learned that in chemistry. We are not going to discuss that in detail. But he said electrons, when moving in the orbit, they are no longer a particle, they are like a wave, because they are moving at very high speed. So they should have the wave properties, the radiation properties, right? The angular momentum, he said that mvn Rn should be equals to nh by 2 pi. Now this is nothing new. We know that angular momentum in our linear motion is given by mvr, right? In this case mvn Rn, right? So from here you can find that Vn is basically proportional to n by Rn. Okay, so the velocity of electron orbiting around any orbit is proportional to n by Rn. Now Rn again is proportional to n square. So we can say that Vn is actually proportional to n by n square, that is Vn is proportional to 1 by n. Okay, this is also one of the important relations. So velocity of electron orbiting in an orbit of nth orbit, then it should be proportional to 1 by n. Velocity of electron orbiting in nth orbit is proportional to 1 by n. So higher the orbit, slower is the electron. Closer to the atom, closer to the nucleus, higher is the speed, because in that case n is equals to less value. For example, ground state, n is equal to 1. So velocity is very high. If it is goes to say third excited state where n equals to 2, okay, so in that case velocity is half that of the velocity when it is orbiting in the ground state, right? Now the Bohr model is applicable to hydrogenic atom. So that means it is only applicable for hydrogen atoms. It cannot be extended even to mere 2 electron atoms such as helium. Okay, so the Bohr's model is also not correct, it is also flawed, but at least Rutherford model, which was not applicable for any of the atoms, in fact our universe should have died after 10 to the power of 8 seconds. Now at least it has able to discover that okay, it is true for hydrogen atoms. So there are some drawbacks. So whenever a new theory is developed, okay, first theory is completely flawed, second theory is somewhat flawed, third theory is again 50% correct, then after that, after few iterations, we achieve the correct theory. Okay, so theory or physics or anything in life cannot be developed in one go. Even if you are suppose you are planning to write your PU exam. So if you are writing your PU exam, you cannot wake up today and you will say okay, I will go and write my PU exam tomorrow. Not possible. You have to write some mock test, you have to practice, then only you can go and write your PU exam. Similarly for KCET exam, if you wake up and you decide okay, tomorrow I will write KCET exam, not possible, you have to practice it, right? Similarly any theory when it is developed initially, there is no one to practice, right? So they will practice with new theory. So some theory came, so it was failed miserably. Then the second model came, second theory came, it was somewhat correct but only limited to hydrogen. It was not able to explain anything beyond hydrogen. So another theory would have been come, and they later on the correct theory was there, but we are not going to discuss. While Bohr's model correctly predicts the frequencies of the light emitted by the hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies in the spectrum. So even though the value of the frequencies are correct, so if you remember the Lyman series, Balmer series, Paschen series, okay, the frequencies were correctly predicted. Okay, what all the lines, that is correctly predicted. But why some lines are stronger, some lines are weaker? According to Bohr's model, every line should be of equal intensities. But we have observed that certain lines in Lyman series, even in single series, suppose consider Lyman series, one line is very prominent, very bright, whereas one line is very not prominent, not so intense. Why it is so? So that part was also not been able explained by Bohr. So these are the two major drawback of Bohr's. Okay, now let's solve a numerical. Okay, the frequency of revolution of an electron revolving in the nth orbit of hydrogen atom is proportional to. So they have asked you to frequency. What is frequency? If you remember angular frequency, okay, angular frequency or omega is 2 pi f. Here f is the frequency, right? If you remember AC chapter, Okay, all things are related. Okay, frequency is the same thing, expression for frequency is same thing. So frequency is nothing but omega by 2 pi. Even though we don't need the 2 pi term, we can only use the term omega itself here. Now what is omega? If you remember your first few concepts, okay, V equals to R omega. Okay, V is equal to R omega, so we can write here Vn equals to Rn omega. So what is omega? Omega is nothing but Vn by Rn. Okay, if you remember the relative relations, you can answer this. Now what is Vn? I told you Vn proportional to 1 by n. Okay, and also we know that Rn is proportional to n square. So that's why I said for KCET you don't need to remember the exact expressions. If you know the proportionality relations, you can answer all the questions. Okay, so Vn is equal to 1 by n and Rn is already in division and it is proportional to n square. So omega is proportional to 1 by n cube. Now omega is proportional to 1 by n cube, so f is directly proportional to omega, so f should also be directly proportional to n cube, 1 by n cube. So correct answer is option C. Okay, clear? This is a little bit tricky question, that's why I solved it during our discussion. If some question, same question comes again in your upcoming KCET 2025, you should be able to answer that. Okay, now next question. The radius of hydrogen atom in the ground state is 0.53 angstrom. Okay, after the collision with the electron, it's found to have a radius of 2.12 angstrom, the principal quantum number n of the final state of the atom. So very important, we know that Rn is proportional to n square. Also we know that Rn is equals to n square R1. Right, R1 is the ground state. Sometimes it is denoted by R0. To avoid confusion, I am using R1 because that is n equals to 1 value, right? Now, what is Rn? Rn given here is 2.12. This is the higher excited state. And we don't know what is n square, and the ground state is given by 0.53. Right? So, n square is equals to 2.12 divided by 0.53. Okay, so 0.53 means if you approximate that, you can do this by 2 by 5, 2 by 5.5, 2 by 0.5 means 4, right? 0.5 means 1 by 2, so it will go up and it will be 4. Or you can do the calculation, you can remove the decimals, you can cancel it, you will get the same result 4. So n square is equals to 4. So n equals to 2. Right? So most students will answer n equals to 4 in this case, but smart student, the student of my class, will be answering 2 in this case. Right? Got it? Now there is no homework because tomorrow we are going to do PYQs from this chapter. So I will not get time to solve the homework questions. So I have no homework today. Tomorrow I will be back with the PYQs. And if you are thinking where you can get all the lectures, there is a dedicated playlist for this KCET Physics section. So you can visit our channel, you can bookmark the playlist and you can see at your own time. Don't fall behind too much. I request you try to complete the videos as soon as they are released, or maybe within 2-3 days. Don't fall behind, don't create backlogs, so that you are at right place for KCET 2025. And most importantly, you have to join our WhatsApp group for all the updates, for the PDF of the lecture. A link is given in the description below. And if you think this is helping you, don't forget to give it a like and share with your friends. Subscribe to our channel. Thank you. Tomorrow I will be back with atoms PYQs.